2017 question 2b. A ship P is moving north at 15 kilometers an hour, and a second ship Q is 10 kilometers west of P. Okay, well, let's do that diagram. Q and P, 10 kilometers, and a second ship Q appears to be moving relative to P, so the velocity of Q relative to P, which we know is the velocity of Q minus the velocity of P, and the relative direction is 60 degrees east, 60 degrees south at 15 root 3 kilometers an hour. So velocity of Q relative to P is 15 root 3 by the cos of 60 in the I direction, and let's just get the direction here. East south is positive negative, so negative 15 root 3 sine 60 in the J direction for my velocity of Q relative to P. If we tidy this up, the sine of 60 is root 3 over 2, so the cos of 60 is a half, so we're going to get 7, but dividing this by 2, 7.5 root 3 in the I direction, which should be in there, and we're going to get 15 root 3 just off to the side. 15 root 3 by root 3 over 2 is going to give 45, 3/15, 45 over 2, 22.5 in the J direction. So that's the velocity of Q relative to P. Find the velocity of Q. So we have the velocity of P is 15 in the northerly direction, so it's going to be 0 in the I direction plus 15 in the J direction for P going up like this. So we want the velocity of Q in part 1. So we just tidy this up. Velocity of Q relative to P has velocity of Q in it, so I need to bring this one over and add it. So the velocity of Q is going to be the velocity of Q relative to P plus the velocity of P. We have Q relative to P above here. It's 7.5 root 3 in the I direction, and we'll have a plus 0. Just leave the 0 there from here, and then we're going to have plus, going to have the 15 and the minus 22.5, and that will be in the J direction. So the velocity of Q is going to be 7.5 root 3 in the I direction minus 7.5 in the J direction. The magnitude of this is the square root of 7.5 root 3 squared plus 7.5 squared, and the angle theta we'll call is equal to the inverse tan, the direction it's traveling, of 7.5 over 7.5 root 3. Oh, that's the same as 1 over root 3, so theta is equal to 30 degrees, and the magnitude of the velocity of Q using a calculator, this works out to be an even 15 kilometers an hour. So that's Q, that's what's going on with Q. Then find the value of theta 2 minutes after the time when P and Q are closest together. P is east, theta degrees north of Q. Okay, let's continue this QP diagram here. When they're closest to each other, Q is going down in this direction relative to P, positive negative. Here's my closest direction. We have my Q, my P, my 10, and we got the angle, the relative angle. Be careful now, the angle it's actually traveling at is 30, but the relative angle was 60 up top there. So this is 60, make this one 30. So we get x here. X is going to be 10 sine 60, or sine 60 is equal to x over 10. To get that 10 sine 60 is equal to x. Sine of 60 is root 3 over 2, so x is 8.66, I think. 8.66025, so 8.66 kilometers. So now it's gone here, it says 2 minutes later. 2 minutes after the time when they're closest together, so that's along here. So Q is traveling relatively in this direction here. At what speed? The relative speed of Q. And that's from up here. If it's 15 root 3, just check up above there. Appears to be moving at this speed. So I suppose that's the mistake you can make here, to take the actual speed it's moving at. So 15 root 3, 2 minutes is 2 over 60 by 15 root 3, which is 30 over 60 root 3, which is root 3 over 2 kilometers. 2 minutes later, that's this guy in here. So what have we got? We have a right angle triangle. We can get this distance if we need. What do we ask for? We're asked for this angle. I think we're asked for the angle, so it's going to be this total angle here will be the angle we're looking for. So I got the side x. Let me call this one in here A. The tan of A is equal to opposite the root 3 over 2 divided by adjacent, which is the x that we got to be, well, I have it in terms of 8.66, but 10 root 3 over 2 is 5 root 3. These will actually cancel, so that's dividing by 5 root 3 over 1 would be multiplying by 1 over 5 root 3. So I'm going to get 1 over 10. The tan of A is equal to 1 over 10. So A is equal to the inverse tan of 1 over 10, giving me 5.71 degrees. So the total angle then is 35 plus 30 is 35.71 degrees. And they're calling that theta. Actually, we give it theta. A is equal to theta. Therefore, theta is 35.71. And then in the last part, if Q can be seen from P for 12 minutes, find the distance between P and Q at the end of this time. So 12 minutes this time. Okay, for 12 minutes, when we had 2 minutes along here was root 3 over 2. So 12 minutes is going to be 6 here. And say 6 here. So we can get, say, this direction here, or this distance here, if that's the 6. So 6 minutes is going to be 3 times that guy. So 3 root 3 over 2 will be 6 minutes. We already have x is equal to, what do we get, 5 root 3. So this diagonal here, y is going to be equal to the square root of 5 root 3 squared, this will be the distance between them, plus, we get a 3 root 3 over 2 to be squared. So this distance works out to be 9.04 kilometers.